Welcome back everyone, Patrick here, and in this next video what we got to do is we got to find the domain and range of these three parabolas here. So notice we have three quadratic functions. They're all given in different formats though, so we're going to go about it in different ways. Now, first thing I want to mention, the domain of all of these, of any quadratic, is always what? It's always x is an element of real numbers. It could be any x value for all three of these for any quadratic, because if you take the standard parent function x squared, no matter how you transform it, whether you shift it left, right, up, down, whether you stretch it, compress it, flip it, it's always going to cover all of the x values, because this is going to keep going this way, or if it's facing down, it's going to keep going that way. Right, so the domain of any parabola is always going to be XER. So that's going to be the domain for all three of these. Now, what's going to change is the range, because the range depends on the vertex of the parabola. And so we're going to find the vertex for all three of these in a different way. Now, the first one, y equals 5 minus x squared, I'm actually going to rewrite this as negative x squared plus 5. And this one's fairly easy to find the vertex for, because you could just take x squared and apply transformations to it. So notice the negative in front, it flips it over the x-axis, so it would look like this. And then the plus 5, that's the c value, the transformation c value, that shifts it up. And so you'd end up with a parabola. Let me draw a new one here. That basically opens down, and the vertex is going to be at 0 and 5, like that, right? So we took x squared, the parent function x squared, flipped it, and then shifted it up by 5 units. So the vertex is at 0 and 5, and so from there, it's obvious to see what's the range going to be. Well, it's basically going to be y can be any real number, but y has to be less than or equal to 5. Right? All the y values have to be less than or equal to 5. So the range of a quadratic is always going to be y has to be either less than or equal to the y value of the vertex if the quadratic is opening down, like it is in this case, or it's going to be y is greater than or equal to the y value of the vertex. It's greater than or equal to if the parabola is opening up. In this case, it's opening down, so it's less than or equal to 5. Another way this could be shown is you could say the range would be from negative infinity to positive 5, but it's inclusive of the positive 5, so you would put a square bracket there. Right? So whether you show it in set notation or interval notation, that's the range of this parabola over here. Now, what about the next one? We have x plus 4, y equals x plus 4 times x minus 2. So notice this is in factored form here. And so notice that we can get the x-intercepts here because it's in factored form. So we can have x equals negative 4. Here we'd have x is equal to 2. Those are the x-intercepts. At those x values, the y value would be 0. If we plug in negative 4, this bracket would be 0. So we'd have 0 times negative 6, which would give us 0. So negative 4 and 0 is a coordinate, an x-intercept. If we plug in 2, this bracket would be 0. This would be 6, but this would be 0. So 6 times 0 would give us that y value of 0. And so if we show this, we'll have, let's try to make it to scale here. We'll have negative 4 as an x-intercept, and then we'll have 2, positive 2, as an x-intercept as well. Now, if we were to expand this, notice how the first term would be x squared. So it has a positive leading coefficient of 1, meaning that it opens up. And so if we draw this parabola, it would look something like that. What we want though is this over here. We need the vertex value, more specifically the y value of the vertex in order to get the range. So the way we can get that is the x value of the vertex is always going to be in the middle of the two x-intercepts. And we have the two x-intercepts, -4 and 2, so what we could do is we could just add them and divide it by 2. So this would be -2 divided by 2, which would give us -1. Right, so notice -1 is in between -4 and 2. It has a distance of 3, distance of 3. And so we know that the vertex is going to have an x value of -1. And we can get the corresponding y value by just plugging in -1 into the function. And when we do that, we would end up with -1 plus 4 would give us 3, and then -1 minus 2 would give us -3. And so we would end up with -9, like that. So -1, -9 is the coordinate of the vertex for this particular parabola. And so notice that we have the y value of the vertex, so basically the y values have to be greater than or equal to -9. Right, so it would be, the range for this one would be, y can be anything as long as y is greater than or equal to -9. Or if you want to put it in interval notation, we would say all the y values from -9, inclusive of -9, so we put a square bracket there, to positive infinity, like that. Right, so domain, XER, and then that's the range for this parabola, part B. Now part C, it's a little more tricky because it's a full standard form. This was in standard form too, but we didn't have the b value to worry about. Right? It was just x squared and then 5, the constant at the end. So it was easy to show the transformations. Here, it's a little bit more difficult. You can't see the transformation. So what I do personally is I take something like this. First off, I usually check if I could factor it to put it in this format, but you can't factor this. Notice that there's no two numbers that are going to add up to +15 and multiply to +15 and add up to +12. So factoring is not going to work. So what you could do is you could complete the square on this. You could change this to vertex form. So the way you would do that, you would take out a -3 from the first two terms. Right? You may have to go back and watch completing the square videos. If you have trouble finding them, you could just let me know and I could point you to them. But what I'm going to be doing here is completing the square on this to take this standard form, put it into vertex form, and then we can know where the vertex of the parabola is going to be. So you take out a -3 from these two, and then you'd end up with -3x squared minus 4x. Now what you want to do here is -4 divided by 2 is -2, and then you want to square it, which would be +4. So you go +4 minus 4, and then you'd have a -5 like that. So it's like we're adding 0 here. The reason why you want to do this is we take the -4 out, and then when we take the -4 out, we have to multiply by this -3. So we'd end up with x squared minus 4x plus 4 plus 12 minus 5. And now this will always be a perfect square trinomial. This is going to factor into x minus 2 squared, and then 12 minus 5 gives us 7. So this quadratic and this quadratic, they're the exact same thing. And now that it's in vertex form, notice that we can see what the vertex is. It's going to be the opposite sign here, 2 and 7. And then it's a parabola that's opening down because of that -3, and we could see here the a value is negative as well. So basically this parabola, the vertex is at 2 and 7, which is approximately here, and it's opening down. And that's all we need to know for the range. All the y values have to be less than or equal to 7. We don't even need to know what the x-intercepts are or the y-intercept or how it's going to look down here. We just need to know that we just need to know the vertex and that it's opening down. And that's enough information to get the range. So the range here would be y can be any real number, but it has to be less than or equal to +7, or in interval notation from -infinity to +7 inclusive of that +7. Right, so the domain for all three parabolas is XER. The range are these respective expressions.